6.1a is about simplifying nth roots. So first we need to talk about irrational numbers and rational numbers. Okay, so an irrational number is a number that can't be written as a fraction. A rational number is a number that can be written as a fraction. So as we're talking about roots or radicals, an irrational number is a root when the radicand is not a perfect square, and a rational number is the root when a radicand is the perfect square. Okay, so just keep those definitions in the back of your mind as you're watching the rest of the video. So radicals, that's what Unit 6 is all about. Radicals are also referred to as roots, so they're the same thing. And basically you're asking what times itself the index number of times equals the radicand. So if we're looking right here, we have a radical. So this shape right here, kind of check mark with a line on the top, that's our radical or our root. Right here, we're taking the third root of the number 8. Okay, so the radical symbol, again, is that check mark shape. The index is this number outside, and the radicand is the number inside of your radical. Okay, so basically, right here, this is asking, what times itself 3 times equals 8? Well, 2 times 2 times 2. Okay, so the cubed root, or the third root of 8, would be 2. Basically, radicals are the opposite of exponents. So exponents, if you had 2 to the third, it was telling you to take 2 times itself 3 times. A radical is undoing that action. Okay, so radicals and exponents, they're opposites. They would cancel each other out, just like addition and subtraction are opposites. If you add 5 and then subtract 5, they cancel each other out. So let's take a closer look at square roots. Anytime you have a radical like this where it doesn't specify the index number, it's always going to be a square root. That's the most common. When we were talking about exponents, we said x squared. Okay, was saying, well, x times itself, so square root. That's what it's talking about. It's talking about taking something multiplied by itself. Okay, so just a reminder about our exponents. If we had 5 times 5, that would equal 5 squared. Okay, so 5 squared equals 25. So that's our exponents, or our squared, 5 squared. When we're talking about radicals, we're basically going backwards, right? We're undoing this. So the square root of 25, we could write as the square root of 5 times 5, okay, which equals a square root of 5 squared. Well, since the square root and squaring are opposite, okay, the square root of 5 squared is just the number 5. So if we're answering this question, we are saying that 5 times itself 2 times equals 25. So this is what a square root is. This is what you're doing. Again, it's just the opposite of an exponent. We have rules for simplest form for radicals, just like we had rules for simplest form of exponents. So these are 3 things you're going to want to memorize as soon as possible. So when you're done or in simplest form, there are no perfect squares in the radicand. So this is a non-example, right? So 25 is a perfect square. We'd have to keep simplifying that. There are no radicals in the denominator. Well, here we have the square root of 3 in the denominator, so we'd have to keep simplifying that. And there are no fractions or decimals under the square root. Right here we've got a fraction, right here we've got a decimal. Okay, so again, these are not examples. These are the rules. This is the questions you ask or the things you look for in order to determine if you are in simplest form or not. So let's practice, okay? I think practice and it'll make a little more sense. We want to simplify each expression. So we want to make sure that there are no perfect squares under any of these radicals. And notice all of these are square roots because there isn't a different index on our radical. So we're going to just start off by factoring the number 90. If we want to take the square root of 90, we're going to start by factoring. Well, I know that 9 times 10 equals 90. Well, I know that 3 times 3 equals 9, and 2 times 5 equals 10. And that's pretty much the lowest we can go for all of those, right? 3, 3, 2, and 5 are all prime numbers, so we're done factoring. So we want to see if any of these are perfect squares that we can take out. So we're looking for groups of 2. Well, right here we have 2 3s. So we have a 3 squared that is underneath our radical. Then our other factors are a 2 and a 5. Well, there's just one of each, so we aren't going to do anything with those. So if we break 90 up, we could say the square root of 90 is equal to the square root of 3 squared times 2 times 5. Okay. So now we're going to actually try and evaluate this. Well, we're going to look one at a time. So the square root of 3 squared we just talked about, they'd cancel each other out, and that would leave us with 3. The square root of 2, we can't actually do that, okay, because 2 is not a perfect square. There's not a whole number times itself that gives us 2. Same for the square root of 5. There's not a whole number times itself that gives us 5. So those just have to stay under our radical. Okay, so to finish this off, we would have 3 times the square root of 10 is a simplified form of the square root of 90. All right, so essentially all we're doing, we're looking for groups of 2, and we are squaring those to get them out of our radical. So this will be a good time to try and do letter B. So 75, well, I know that 3 times 25 is 75. Well, 3 is prime, but 25 is 5 times 5. So again, I'm looking for groups of 2. So I notice I've got 2 5s. So I could write the square root of 75 as 3 times 5 squared. Okay. Well, the square root of 3, nothing times itself, right? No whole number times itself gives us 3, so we just have to leave that in our radical because we don't want any irrational numbers. The square root of 5 squared, well, again, those are opposite actions. They cancel each other out. So we just have a 5. So the square root of 75 is equal to 5 times the square root of 3. Let's practice a couple more, but we'll throw in some variables. Okay, so we're just going to take it one piece at a time. Well, 16 is the same as 4 times 4. Well, that's already a group of 2, so we can just stop there. A cubed, well, A cubed, if we write it out, would be A times A times A. So we have A squared and then an extra A. So we can see the square root of 16 times A cubed is the same as 4 squared times A squared times A. So I just took my groups of 2 and I wrote them using an exponent. And then my leftovers are just taken along at the end. Well, the square root of 4 squared is 4. The square root of A squared is A. And we can't take the square root of A to the first power, so that just stays under our radical. So the square root of 16 times A cubed is equal to 4 times A times the square root of A. So it'd be a good time to pause and try and do letter D. Okay. Well, the square root of x squared times y to the 5th. Well, x squared, that's already a group of 2. Right? So I'm going to rewrite that. That's already a group of 2. We don't need to change that. Y to the 5th, well, that's y times itself 5 times. So I'm going to go ahead and I'm going to circle groups of 2. I have 2 y's here. I have another group of 2. And then I have a y taken along at the end. So I will have y squared times y squared, right? 1 for each group, and then just that extra y taken along at the end. Well, square root of x squared is just x, square root of y squared is y, square root of y squared is y. Can't take the square root of y to the first power, so that has to stay under the radical. Okay, it's just stuck there. It's like it's in jail. So we can simplify this one step farther. We can say this is x times y to the second times the square root of y. And that is our final answer. Last part, we have something called nth root. So we've just been looking at square roots. So that's, again, when we just have that index of 2. But we could have nth root, so we could have the 3rd root, we could have a 4th root, 6th root, 5th root, 10th root, 100th root. Okay, you could do this for anything, but we're just going to focus on square roots, cubed roots, and 4th roots. Okay, so cubed roots is the same type of idea as square roots, except we're going to be looking for groups of 3 instead of groups of 2. Okay, but we're still going to start off by factoring. So if we have the cubed root of 80, let's start by factoring that. Well, 80 is 8 times 10. Okay, 8 is 2 times 4, 10 is 2 times 5. Then we could break 4 down into 2 times 2. So very similar to square roots, but now we're looking for groups of 3. Well, right here we have 3 2's. So let's go ahead and rewrite our square or cubed root of 80. Well, 2 times 2 times 2 we can write as 2 cubed. And then we just have 1, 2, and 1, 5 left over. So we just have those tagging along at the end. Okay. So just a squared root and a square cancel each other out. A cubed root and a cube cancel each other out. So the cubed root of 2 cubed is 2. So that's going to come outside of our radical. Well, 2 and 5, if we took the cubed root, we wouldn't get whole numbers. So they just have to stay in our radical. Again, it's kind of like staying in jail. But we could multiply them together to get 10. So the cubed root of 80 is equal to 2 times the cubed root of 10. Now would be a good time to pause and try letter B. Well, 81 we can break down into 9 times 9. And then both of those break down into 3 times 3. Okay, p to the 5th we could write as p times p 5 times. And then q to the 3rd would be 3 q's, but notice q to the 3rd is already a group of 3. So we're going to go ahead and we're going to find those groups of 3. Maybe you want to pause and try that. We've got 3 3's right here, so let's go ahead and write that in our radical. We'll have 3 cubed, and then we just have 1 extra 3 taken along. Well, then we've got a group of 3 p's, so that's p cubed. And we have 2 p's taken along, but we can write that as p squared. And then last but not least, we have a group of 3 q's, so q to the 3rd power. And now we are evaluating this. So the cubed root of 3 cubed is just 3. The cubed root of 3, well, we don't have a group of 3 there, so that just has to stay in our radical. The cubed root of p cubed is p. The cubed root of p squared, well, we don't have a group of 3 there, so that just has to stay in the radical. And the cubed root of q to the 3rd power is just q. So we simplify this down to 3 times p times q times the cubed root of 3 times p squared. All right. Last but not least, let's take a look at 4th roots. So same type of thing, except we are looking for groups of 4. All right, so let's break down 64. Well, 8 times 8. And then we can break 8 down into 2 times 4, 4 down into 2 times 2, and we can do the same with this other 8. Okay. M to the 6th power, well, if we want to write that out, I have to make a little bit of room here. That'd be 6 m's. Okay, n to the 4th power, notice how that's already a group of 4, but we'll write it out anyway. And then p to the 8th power is 8 p's. Okay, so now we're looking for groups of 4. That'll be a good time to pause and maybe try to finish this one up for yourself. Looking at our 2's, we've got 4 2's here and then 1 extra. So I'm going to go ahead and I'm going to write that in my radical. So I have 2 to the 4th power times that extra 2. Okay. Looking at my m's, I have 4 m's, so that's m to the 4th. And then I've got an extra 2, so that's m squared. Looking at my n's, I have 4 of those, so that's n to the 4th. Looking at my p's, I have p to the 4th, and then another p to the 4th. All right, so now we are ready to actually take the 4th root. The 4th root of 2 to the 4th is 2. Okay. We can't actually take the 4th root of the number 2, so that just has to stay in our radical. Well, the 4th root of m to the 4th is m. The 4th root of m squared, well, we don't have a group of 4. Okay, so that has to stay in our radical. The 4th root of n to the 4th is n. The 4th root of p to the 4th is p, and the 4th root of p to the 4th is p. So we simplified everything. The very last thing we can do here is to write this as p squared. So we'll have 2 times m times n times p squared times the 4th root of 2 times m squared. And that, my friends, is our answer. A lot of new information, so we're going to be working on this the next couple of days in class to make sure everybody understands what's going on. So come with your questions. Start to memorize what it means to be in simplest radical form. Remember to answer the questions at the bottom of your quiz.